16? You don't know? We are on the back of, or no, the front of 16, right? Of the notes?
Is it a new packet?
No. No. We haven't had a test yet over this, so it's the same note packet we have. So we're on page 16. And we've already done this part, but I'm going to go ahead and redo it because we need these answers. So here we go. This is another, okay, so we buy bananas from stores P and Q. 70% come from P, 90% come from 70 come from P, 90% are delicious, 80% from Q are delicious, okay. So what we have, what are the two things that are happening in the problem? We're buying bananas, and what about these bananas? They're either delicious or not, so that's one of the things. What's the other thing? Read the first sentence. They either come from store P or Q. So we're getting bananas that are either delicious or not delicious, and they come from store P or store Q. Now, what's the ultimate question? The question that's asked in problem A is the banana delicious? Right? So that becomes the second part of the problem. So the first part of the problem is we're coming from P or Q. What is our percentage for P and Q?
0.7.
For P is 0.7, so Q then would be 0.3, yep. And then we're going to be delicious or not delicious. So what's the probability we're delicious if we come from P? Okay. Delicious from P. 0.9 and 0.1. And then what about from Q? 0.8 and 0.2. So the question is in A, find the probability that we're delicious. So we'd be looking here and here. So we're going to, I can do this without a calculator. We're going to multiply these, right? So that's 0.63. And then we're going to multiply these, and that is 0.24. And then we're going to add those together, the probability of being delicious. The total probability of being delicious is 0.87. Is that right?
Yes, ma'am.
Okay. So that's easy. Now this next one is kind of an honors question. And I think we maybe did this a little bit, maybe not. But anyway, this is a tough question. This is like a bonus question. If I pick a delicious banana, what is the probability that I got it from Q? Now, it's a probability question, okay? So it's a fraction. And what is the denominator? In every probability fraction, the denominator is what? The total, right? But in this case, the total isn't the total of every banana in the world. The total is if I pick a delicious banana. So I'm only picking from the delicious ones, right? So my denominator is the delicious bananas, which is 0.87. If I pick a delicious banana, I'm not picking from all the bananas. I'm picking from only the delicious piles. So that's 0.87. What's the probability that I got it from Q? So in other words, what's the probability that it came from this branch? This is the Q delicious branch. Well, what is the probability of that branch? 0.24. So the answer to the question is actually 0.24 divided by 0.87. 0.24 divided by 0.87. So what is that? Somebody do that on your calculator?
0.2759.
0.27. Well, it can't be 2 point something.
Or 0.275.
0.275? 9? So 0.24 divided by 0.87. What makes that tricky is you have to really read the question carefully. and know that the denominator is just the delicious bananas, because it says, I am going to pick a delicious banana, period. So I'm only picking from the 2 delicious piles. That's a total of 0.87. Okay, if I buy 2,000 bananas, how many can I expect to be not delicious? So this is an expected value problem. Who was here yesterday? Okay, well, I don't think you were you here when we were doing all these? We did like 30 of these.
Wait, Kyle, were we here? Allie, I think you were here.
So expected value, how do we make a prediction and find an expected value? We take the number of trials, which is 2,000.
Yeah, I was here.
The number of trials is 2,000. And what do I multiply that by? The probability of getting what I want. Now, what is the what do I want? What does it say? Not delicious. It says not delicious. So how do I figure out the probability of not delicious? I could do this branch, right? And that would be 0.07. And then I could do this branch, this branch right here, and that would be 0.06. And then I add those together, did you get 0.13? I could have figured that out a different way. What was 0.87? The probability of being delicious. So what, doesn't it make sense that not delicious would be 13%? But it's okay, you can do it either way, that's fine.
So you can, the second one that you just said, the second way, you can always use that.
Yep.
Like just.
Yep. So, what is this? 260? So we can expect, oh no, these aren't, those are bananas, not people. We can expect that 260 of these bananas will be not delicious. Right? Okay. Now we're going to do the next problem. I'm not going to give you any of those hard ones like B, but you are going to have to be able to do this, find expected value. So to find expected value, if somebody's asking you, make a prediction how many will be good, or how many will be bad, or how many will get A's, or how many will stay in a hotel. When you're making a prediction, you take the number of people or bananas or whatever it is, the number you've got times the probability of what you want. All right, class contains 10 boys and 12 girls. 4 students are randomly selected. What is the probability of at least one boy? Okay, now wait. We're picking 4 students. What is that noise? Oh. We need, what's the probability of at least one boy? So what can happen if you pick four kids? What can happen? You can get all boys. You can get all girls. You can get all girls. I'm going to kind of do that down here. You can get all girls. We could get 1 boy and 3 girls. We could get 2 boys and 2 girls, right? And we could get 3 boys and 1 girl. Yep. So these are the different options that we have. Everybody in agreement if you pick 4 people? Now, here's the issue. This one's easy because this would be boy, 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 boy. That's easy. But when we say 3 boys and 1 girl, different orders, right? So it could be boy, 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 girl. It could be boy, girl, boy, girl, or boy, boy. Boy, boy, girl, boy, or girl, boy, boy, boy. I don't really want to go through because there's going to be a bunch of for all these, right? The one on the end is easy. This would be girl, 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 girl. That's easy. There's only one order for that. Okay? Now, I want you to think about this for a minute. think about a tree diagram. You could draw a tree diagram. The first kid you picked can be a boy or a girl, right? And then the second one you pick can be a boy and a girl. It's going to be a big tree diagram. But you could find all of these branches on the diagram. But here's what I want you to think about. The problem says, what is the probability of at least one boy? Doesn't at least one boy include all of this?
Yes.
The only thing at least one boy doesn't include is what? All girls. So instead of doing the whole tree diagram, what if I just did this piece of it? Now, these all have other branches, for sure, but I don't need all those other branches because I want girl, 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 right? If I'm doing this one. So I've got this bucket of people, there's 22 of them, and I'm gonna pick one out. What's the probability she'll be a girl?
Can you add them all? Add all the girls together?
What's the probability my first person will be a girl? 12 over 22? Why is it 12 over 22?
Because there's 12 girls out of 22.
Exactly. So I've reached in and grabbed a girl, and now she's sitting here. Now I'm going to reach in and grab another girl. What's the probability I'll get another girl? 11 out of 21. Because I already took a girl out, so there's only 21 people, and 11 of them are girls. Okay, so now I got my second girl. Here she is. Now let's reach in and grab another one. What's the probability she'll be a girl? 10 20ths. And finally the last one, because I need 4. 9 19ths. Now, understand that all of these have other, all of these have other branches, plus all of these have branches, and these, I mean, we got, this tree diagram would be huge. But we don't care about any of it except all girls. Hang on, you'll see why in a minute. All girls is easy. I'm just gonna, what am I gonna do with all these fractions? Am I gonna add them? I'm gonna multiply them. Why am I gonna multiply them? Because it's a girl and a girl and a girl and a girl, right? When it's and, I multiply. So take out your calculator. 12 22nd, so 12 divided by 22 times 11 divided by 21 times 10 divided by 20 times 9 divided by 19 equals. And tell me what you get. I need somebody to say it loudly and clearly.
0, 6, 7, 7.
Yeah, I got 0.0677.
Yeah, perfect. Now, what does that number represent? What is that? That's the probability of all girls. Now, the question didn't want the probability of all girls. The question wanted all the other things.
Yeah, so subtract that from 100.
Exactly. Subtract it from 1, and that will be the answer to the question. This Venn diagram will have 16 branches. You could go through and do this on every branch. But why would you do that? 15 branches is a ton of work. To get these other 15, we'll just take 1 minus that. So what is the answer to the question? 0.9323. 323. In math land, we call that going through the back door. Instead of finding what I actually wanted, I found what I didn't want and subtracted. Because it saved me a ton of time to do it that way. Okay? gotta just venture in your notes there, pause for a moment. I got a new concept for you before we start in on our card problems, which we're getting ready to start in on. We need to talk about the mathematical notion of a combination. We use combinations when we are choosing items without regard to order. So if I am forming a committee, for example, I'm going to pick 3 of you to be on my committee. When I choose you, it really doesn't matter what order I choose you in, right? I'm just going to pick 3 of you to be. That's a combination problem, okay? So we normally have, I think 24 in our class. So the way that would be written, if I wanted to know how many ways I could choose a committee of 3 from my class of 24, it would be written like this or like this. You need to be familiar with both notations, and that means you are going to choose 3 kids out of 24 with no regard to order. Order doesn't matter. So how many ways can I choose 3 from 24? That's what this notation means, okay? Your calculator will do this for you. So get out your calculator. I gave mine away, so I gotta look over your shoulder to make sure I get the right. Okay, so the first thing you want to do is press 24. Okay? Now, remember your math button that we've been using there in the first column?
Yes.
Press that and click across the top, math. Click across the top. See prob?
Yeah.
Last option. Click over there. Press enter. And then when you go down that column, do you see an NCR button? That is your combination button. This is like the N, the CR. So press that button. Then press 3. And then press enter. And it will tell you how many different committees you
Go
can
to
have.
prod, then you go to
Go to the NCR, and press 3. I'm not sure why you have to do
Will, can you help me? Will. I go to math, prob,
2024?
and then enter.
And then 3.
So how do you do it, Miss Ford? It's not like
Now, there are lots of other buttons in that probability menu, right? We are focused on NCR right now. That's our combination button, because we are choosing things without regard to order. Okay? Now, let's see how we're going to use this on our problems. Consider a standard deck of cards. We're going to draw 3 of them and get all black. Now this is a probability question. So we have a standard deck of cards. Let's make sure we're all straight on what that is. If you don't play cards, you're just gonna have to learn this. Unfortunately, it's just part of the deal. We gotta know what a deck of cards looks like. So how many cards are in a standard deck? 52. How are they divided up? 4 suits. So we have what are called suits, and they are diamonds, clubs, spades, and hearts, right?
Yes, ma'am.
And this one's red, and this one's red, and these are black. So half the deck is red, half the deck is black, right? And there's 13 of each of these, right? Because 52 altogether. Now, within the suit itself, so all the diamonds, what do those look like? You have a 2, a 3, all the way up to a 10, and then you have a jack, queen, king, and ace, right? So if you're not familiar with a deck of cards, get online, look at it, because you need to understand those basic fundamentals in order to do all these problems. Okay, so here's the deal. We're gonna reach into our deck of cards and grab 3. This is problem A. It's a probability question. What goes in the denominator of a probability question? The total. So it's going to be 52C3 because the total cards is 52 and I am picking 3 of them, right? Now, by the way, will that be the denominator for A through K? Yeah, because we're not changing the problem. We're picking 3 cards. Now, the numerator is what I want.
26.
The numerator will be 26C3 because if I want black cards, they have to be clubs or spades, and there's 26 of those. So now I'm going to go to my calculator, and I'm going to type 26C3. I'm not going to write this down. You're just going to type it in. There's no need to write it down. So 26C3, and then divided by 52C3. Don't hit any equals. You don't need to do anything like that. We're just going to do 26 math. Click across to prob, down to NCR3, divided by 52 math. Across the prob, down to NCR3 equals. And you should have gotten 0.1176.
Yep.
Okay? So that's the probability of getting all black. Now, what about all diamonds? What's that going to look like? All diamonds.
13C3 over 52C3.
The denominator we already talked about, that's going to be 52C3 every time. For this problem, that's going to be 52C3. The numerator now is going to be 13C3. Because why? Because there's 13 diamonds, that's right. So if you're not getting the right answer, press exactly what I tell you. 13. Math. Click across the top to prob, down to NCR, enter 3, divided by 52, math. Click across the top to prob, down to NCR, enter 3. Oh my. Did you get 0.0129?
Yeah, I did.
So that means, those of you that are gamblers out there, that means that there's only a 1% chance that if you grab 3 cards, they'll all be diamonds, right? That's not good odds. Don't spend a lot of money. Okay.
This 4. You
Yep.
just had a gamble.
What?
I got an error.
Okay, we're not typing it in right. We'll have to look at it now. Let's get started on the next one. 1 black and 2 diamonds. Okay, well, first of all, our denominator is the same, right? What about the numerator? I need 1 black and 2 diamonds. What does that "and" mean?
You added 2, so
I'm going to be
28.
multiplying. When I have this and that, it's a multiply problem, right? Now, 1 black. What's that going to look like? 1 black. So 26C1. Right? And 2 diamonds.
13C2.
13C2. Remember when you do your combination setup, the first number is how many you have to pick from. There are 13 diamonds. And the second number is how many you are picking. Okay? So you're going to type, you can do this all at once. 26C1 times 13C2 divided by 52C3. And you will get the right answer. So let's all type that in, make sure that we can. 26C1.
My own 916.
Okay, now you need, bring it back up. Times 13C2. Divided by, you need the arrow, yeah, divided by. Okay, the answer should be, if Emmett is right, 0.0918. 0.0918, is that right?
Yeah.
Get that?
Are you in senior spring? You do senior spring?
Yeah.
Huh?
I'll tell you tomorrow during alpha
Why are you gonna get your bracelet?
and tomorrow morning.
Okay, we're gonna do one more.
Wait, it's already a done deal.
Clear up any calculator issues. One more, D, no spades.
Guaranteed to get you.
So I'm gonna reach in, grab 3 cards, so my denominator's 52C3, and I want no space. So what's that numerator gonna look like? I hear somebody saying it, 39C3. Why 39?
Because you subtract the 4 queens, or the no spades.
No space. I don't want any space. So that means I'm gonna have diamonds, clubs, or hearts, right?
Yeah.
And there's 13 of each, so that makes 39. So type it in. Did you get 0.4135?
Yeah.
So actually, that's not too bad. That's about a 40% chance that you wouldn't get any space. Okay? All right, so we are done. Who has a calculator issue? We'll take the last minute or so to take care of that. Who's not getting any of these?